Okay, so we'll go ahead and get started. I just pushed the commit to GitHub, and so you can pull that commit. And when you do, it's going to rename a bunch of files. I thought, you know what, the current file names that I have are not very descriptive or very helpful. So I renamed pretty much all of my lectures. I kept the numbering the same, but I renamed them instead of just calling them lecture stats 21. I gave a short description of what the lecture content is. And I think that will be helpful. You know, if you ever go back to review your notes and things like that, you'll at least have an idea of which lectures and which. So if you do, you know, git pull upstream main, that should update the file names as well. So that's going to be in there. Okay, we'll continue on. Today we're going to take a look at Pandas. Pandas is kind of the very important package or module that we use in Python for data analysis. And so today we'll talk about indexing and arithmetic and working with missing values. And then on Friday we'll continue on in Pandas just because there's quite a bit to cover, and we'll take a look at pivoting and summarizing and things of that nature. So let's go ahead and take a look. So the key thing about Pandas is that everything in Pandas, the series, your data frames, they all have an index, okay? And the index is what's going to be powering kind of a lot of the underlying arithmetic and things of that nature. And so throughout today's kind of lecture, I'm going to be dealing with, I've got a couple series and some sample data frames and things of that nature, okay? So I just want to kind of point out that I have one series here, okay? The original one goes 1.4, 2.3, 3.1, 4.2, and the index that corresponds to it goes DCAB, okay? And D goes with the 4, and C goes with the 0.3, and A goes with the 0.1, and B goes with the 0.2, all right? I also have another series called original 2, and its values are 2.2, 3.1, 1.3, 4.4, and again, the index B goes with 0.2, the index A goes with 0.1, the index C goes with 0.3, and the index D goes with 0.4, just so we can kind of keep track of things. So anyway, if I take original 1 and I just print it out, it creates the series. So if I have original 1, I say pd.series, pandas.series, and the index is DCAB, and it creates the series accordingly with the index in that order, DCAB. Okay, and here I'm going to make make a data frame out of original 1 and original 1 times 2. Okay, and I'm going to call that x and x2. And because both original 1 and original times 2 is going to have the same index, DCAB, it's going to create the data frame, and the data frame also gets created with that index DCAB. No problem there. All right. Over here, original 2 is another series, but notice that the series here, its index, while it consists of the same contents, DCAB, original 2 has the index in a different order, BACD. All right, and so when I create the original 2 series, it comes out in that order, BACD. And what you'll notice is that when I ask Pandas to create a data frame out of original 1 and original 2, which have the same index values but in different orders, Pandas decides, you know what, I'm not quite sure how, should I put them in the order of original 1? Should I put them in the order of original 2? And what it defaults to do, its default behavior, is to alphabetize the index or order the index first, or I guess sort them in case they're numeric or things like that. So in this case, it's going to order them in alphabetical order. And so it creates them in A, B, C, D, and it aligns the values accordingly. So we have X and Y in this order, A, B, C, D. Okay. When you take a series and you slice it using kind of index values, it's going to use whatever index it has, right? So original 1, remember it was created, when it was created, it's in this order, D, C, A, B. And so if I slice it from D through A, it's going to pull those values out, okay? It's going to pull values D, C, and A, okay? Whereas when I've created this index, and when I've created the data frame, by default, this data frame is in the order, in alphabetical order, and so its index goes A, B, C, D. And therefore, when I slice, if I want to get the first 3 rows, I would have to slice from A to C, okay? If I tried to slice from D through A, I would get back nothing, okay? And let me just kind of show you that. If I were to take, so if I, this is, change the data frame here. So if I try to take this data frame and I try to slice it from D to A, okay, it's going to come back with nothing because there's nothing to slice in order, from going from D to A, I can't slice that. I can slice from A to D. I can slice from A to A, that's fine. A to D is fine, but trying to slice from D to A is not going to work, as far as this data frame goes. So you just have to keep in mind which object you're dealing with. So the series, it maintains the original order or of the index that you've created. And when you create it in a data frame, in this case, we made this data frame because it ended up getting sorted because X and Y, they're in different orders. If X and Y were both in the same order, it would have created a data frame with that same order as well. It's not going to just automatically alphabetize, but it alphabetizes it if you give it kind of different series that's in different orders. And it's going to just order them up front. Does that kind of make sense as far as how these series are put together and ordered when we're creating a data frame, and as far as when it happens and things of that nature? Okay. Yeah, you can slice with the -1 operator. Oops. So here's df. And I can do that. Okay. So if you give it the colon -1, colon -1 kind of gives you the step size of going backwards, and then it's going to slice in reverse order. So that's allowed. All right. When you have your series, you can rearrange values, and there's a couple tools to do this. And you basically have sort based on the index, and you have sort based on the values. All right. So here's one of the series that we had created. Original 2, this is what it looks like: 2.2, 3.1, 1.3, 4.4, and the index is B, A, C, D. And so I can say, sort on the index, and it's going to go A, B, C, D. Okay. You can also do sort on the values, and it's going to arrange them from least to greatest. Okay, so I don't think that's any kind of surprise, but it can be applied, as far as the index goes, or as far as the series goes. Okay, and similarly, if I have a data frame consisting of X and Y, you can call sort. Sort index is going to have the same behavior. I mean, it's going to remain the same, right? Because the index has already been sorted into A, B, C, D. But if you had another data frame and you wanted to sort based on the index, you can do that. Here you can specify sort values, and you can specify by. This part for by, it can also be a tuple of multiple columns, just in case you have like a tie. So if you sort based on column X and there's a tie, you can then have, specify in your tuple another column, say column X, then column Y, and then it'll use column Y to sort that and things like that. So, if you have a column of names, last names and first names, you can have it sort accordingly. And then there's other options, such as if you want to put them in descending order, you can say ascending equals false. So the default value is true. And, you can always, just like anything else, you can always look up the Pandas reference, and you can look up Pandas, data frame, sort values, and it will have a bunch of other options that you can specify, right? So if you haven't done so already, you should bookmark or at least the kind of the Pandas API reference as far as how you're going to refer to things. Okay. The index of a series or a data frame is immutable and cannot be modified. So you can't, append values to the index. You can't take the index and just say, I want to change item 3 in the index to something else. That's not allowed. Okay. But you are allowed to just straight up change the index. Okay. And what you can do is you can just define a new index and replace the existing index. So that's allowed. All right. Does that make sense? The index itself, you can't modify. Just like a string, you can't take a string and just say, I want to change the 4th letter to something else. But if you want to just create a brand new string or brand new index, you can do that and just have it replace the existing index. Okay, so here I can take, my series. I can just call, original one, which is our, one of the first series, which I think had the index DCAB or something like that. I can just say, take that original index and just replace it with a range 4 object. Okay. And if I do that, then my values, okay, which originally had the index DCAB, now it just gets replaced with 0, 1, 2, 3. Okay. Because it's the range 4 object just becomes the index. And if we ask, what is the index now? The index now is going to be a range index that starts at 0, ends at 4, step size 1, right? So that's just that's going to just be a range 4 index. Okay, and so now that we've replaced the index with this range, okay, with this range object, we can subset. We can say, all right, what's the value in with index position 1, okay, and using .loc and .iloc will have identical behavior, right? Because the iloc, which uses the index location, the 0-based index location, is exactly the same as our current index. Our current index is a 0-based, range, and so so location 1, index value 1 is the second value, and the value at this, index 1 location is also the second value, 2.3. So these two things are the same. Now, if I want, I can just replace that index again. I can say original.index and replace it with a range 1.5 object. So instead of being 0-based, this is going to be start off at 1. And so if we look at this, then the index starts off at 1, 2, 3, 4, and that's fine. Okay. And therefore, when I ask, if I use single square bracket, it defaults to using the index. Okay. So here, using 1, we'll get the index value at 1. So we get 1.4, right? Back here, when we did original 1, we got 2.3 because it was the 0-based index, right? So index 1 position was 2.3. But now that I've replaced it with a range index that starts at 1, original 1 refers to this first row, okay? And same as .loc, .location 1 uses the index, which is 1.4. And then .iloc, iloc 1 always has a 0-based index, okay? And so iloc 1 is still going to return 2.3, okay? So these two things are going to be different because the index does not start off at 0. Okay, and if you try to ask for something like what is the value at index location A, you get an error, right? This throws an error because, as far as this goes, there's no value associated with index A because we've completely replaced the index. Our first index was DCAB or something like that. We've completely replaced that, so there's no reference to A anymore. So if you ask for, what's the value in the series at location A, you get an error. Okay, and again, I can just replace the index again. And so here I've created a list with the values A, B, C, D. All right, and as far as Pandas goes, there's no check. Okay, when we first created the series, the index was DCAB, And now I'm creating a new index A, B, C, D. And Pandas doesn't care. It just says, okay, we'll throw out this old index and we'll replace it with this new one. And it does it, okay? And so so now the index is A, B, C, D. And basically, and you know, if you do something like this, you can seriously mess up your data, right? So for example, you know, let's say you've imported data and the index values are, you know, people's names or something like that, right? So, you know, this person used to be associated with, you know, Doug's information, right? DCAB. So 1.4 was Doug's, I don't know, GPA or something. Okay. And then now we've just replaced it to be like Alex's GPA or something, right? And that could seriously mess up your data if you've just replaced the index and you weren't careful about trying to check to make sure everything's aligned. Okay, Pandas will just do whatever you tell it to do. There's no check to kind of make sure, right? So A used to be associated with the 3.1, but now it's associated with 1.4. Maybe that's what you want. Maybe that's a mistake. Okay. And then and now that we have an index starting off at using strings A, B, C, D, okay? Using a number here is going to use do zero-based indexing, okay? So if you have a string-based index, like you have here, then this behavior will, putting in a number here, Pandas will default to using a zero-based index, okay? So you kind of have the flexibility of using A, using the name, you know, in our case, string A, or the character, or the number 0, and is going to find the probably the value that you're looking for. Okay. Here, if you try to define the index, so our index, you know, we only have 4 values, A, B, C, D, or 1, 2, 3, 4. And if I try to replace the index using something of a different length, 1, 2, 3, 4, 5, it's going to give you an error. It's going to say, you know, this thing is not going to work. Okay. And so here you can do the same kind of thing with a data frame. So all of the things that on the previous screens were for a series, but the data frame, it works just the same way. If you have some kind of data frame that you've created, you can just take df.index and then just give it a new object to replace the current index. Okay, it used to be ABCD, now it's JKLM, and that's fine. All right, let me go ahead and give you your first view quiz answer for today. It's 5th week Wednesday, and our answer is C. C as in cat. C as in cat is the first view quiz answer. All right, we have a question. It says, what happens if 2 series have different index values and you want to combine them into a data frame? Okay, so yeah, it'll do it. Okay, so here we have, so back here we had the same values, but in different order. Where did it go? Same values in the different order. It puts them, it just aligns the orders and it puts them together. Okay, and then if you have 2 series that are in different, that have different values, it will align them. And then the ones that doesn't have a match in the other, it's going to fill in with an NA. All right, I've got some examples of it coming up later. Okay, so if you have like ABC in one and BCD in another, it'll line up the B and the C, and then it'll have the value for A and a missing value over here, and then it'll have the D over here, but a missing value in this column, if that makes sense. I'll show you some examples. I think it'll make sense. There's something called re-indexing. Okay, re-indexing is different from just replacing the index. Okay, what it's going to do is it's going to take your current object, your current Pandas object, whether it's a series or a data frame, and it's going to create another thing that conforms to the specified index. Okay, so here I'm going to create another series. I'm going to call it original, and again, it has the index DCAB, and I've got 1.42, you know, these numbers here. Okay, And so here's what the original original series looks like with the index DCAB. And I'm going to say I want to re-index this, okay? Re-index this using this index, A, B, C, D, E, okay? And what it's going to do is it's going to take these values and it's going to try to conform them to this. And so here I have an E, and it says, well, I don't have an E here. So it's going to just do its best, and it's going to put in a missing value, right? And so now that I've said A, B, C, D, E, it basically has rearranged these values to conform A, B, C, D, and then it puts in the missing value, a nan, for index E, okay? Because there's nothing there, okay? So it takes the data in the original and moves it to conform to the specified index, and it fills in with NAs. Okay. If you don't want to have nan values here, if you don't like that, you can specify a fill value, right? So you can say fill value equals 0, or fill value equals 1, or fill value equals the mean of that column, or something like that, and you can do this, right? And so here, instead of getting the nan, I get a 0.0. All right. Sometimes you can have ordered data, right? And in this case, it might be desirable to have fill values when re-indexing, right? And so here, I've created a series, okay? And it's got the names blue, purple, and yellow. Those are the values. And the index is 0, 3, and 6, okay? So I have 0 is blue, 3 is purple, 6 is yellow, okay? And so when I re-index it on a range 9 object, which goes from 0 to 8, okay, it's going to conform blue to the 0. It's going to put blue at 0, purple at 3, yellow at 6, and then we have a bunch of missing values. I got nan there, and nan there, okay? And so what I can do is I can do a fill method rather than just doing a fill value, right? Like saying I want 0 here for everything that's missing. I can have a fill method, okay? So rather than just putting in the same value everywhere, I can do what's called fill forward. And so here it's going to take that blue and it's going to kind of push forward that value blue across the nans. So over here we had blue nan nan, purple nan nan, yellow nan nan, and now we get blue blue blue, purple purple purple, yellow yellow yellow, right? We have a question. Is there a simple way to reset the index to 0 based, or would you need to know the range? I think there's a reset index method. And I think this will reset the index. I think reset index will take whatever this is and just create a 0 based index, right? So I think what it does is it takes kind of the current index and it's going to kind of make it a column that you can then drop if you want later, and it's going to add basically a 0 based index here. So there's something called reset index that that I think does what you want. Okay. The opposite of forward fill is backfill. Okay, so we had blue at 0 and purple at 3, and we had nan values at 1 and 2, and so backfill will take the one at 3 and go backwards, right? And then we had nan values at 4 and 5, and it takes yellow and it goes backwards and it fills that up, right? And then obviously there's nothing here to go backwards with, so we still get nans here. Okay, so that's backfill. It's handy sometimes you're dealing with dates and you want to create something called a date index, all right? And there's a whole bunch of different inside the Pandas reference, okay? So here is the Pandas, let's see, under index objects, right? So if you go to Pandas and you go to index objects, there's a whole bunch of things, and there's a whole bunch of pandas.datetime index type of things, right? So you've got years, days, months, quarters, things like that, okay? And so, so you have a whole bunch of things. Kind of a versatile one is the date range function. And so here you can just kind of specify a start date, all right? So here I'm going to say January 1st, 2010. and we're going to ask for 6 periods using a daily frequency, right? And you can specify monthly and quarterly and things like that. And so this will create from January 1st to January 6th, 2010, okay? And in here, I'm going to kind of create a data frame with some prices, some imaginary prices. And we're going to say, 100, 101, we have a missing value, 189, 88, okay? And so here's the data frame. I have this, and then we're going to specify the index using this date index that we've created. Okay. All right. And so, so again, just kind of for reference, here is my data frame. And what I can do is I can re-index it, right? And so if I re-index this going from December 29th with 10 days, okay, it's going to kind of conform the values accordingly. Okay. So we got, so these values going from 100 to 88 from January 1st to January 6th, kind of fill out here. All right. We got 3 days that are missing, or 4 days that are missing, three from December 29th to December 31st. And then we had a missing on January 7th. Okay. And so you can use kind of backfill. All right. And so backfill is going to kind of take the previous value. And so the earliest value I have is January 1, which was 100. And it's going to replace those missing values with 100. Okay. Now you'll notice this nan does not get replaced. Okay. It doesn't backfill this 100 and replace this nan. Okay. And the reason why is backfill, bfill here, only replaces nans that were induced by the reindexing process. This missing value, this nan, was part of the original data. So it's not going to just replace all nan values, right? So this nan was part of the original data. So it's not going to fill this one in. It's only going to fill in the nans that were created as part of the reindexing process, right? I hope that kind of makes sense. Okay. If you're dealing with kind of index values that just exist in your data and you're not asking it to kind of conform it to something new where it's going to introduce some nans and things like that, reindex and .loc pretty much have very similar operation. And so, if I have this data frame, again, DCAB and these values, 1.4, et cetera, if I re-index it, specifying, some arrangement A, B, C, D, okay, it's going to conform the values to that accordingly. 3.1 becomes the first value and D becomes 1.4, or, remains 1.4, but just rearranged. And if I did .location, .loc, and I provided kind of the same argument here, we're going to get the same. Now, just keep in mind, .loc uses square brackets, whereas .reindex uses parentheses because it's a method, and over here this is kind of an attribute here. All right, so these two things behave the same, but the difference here is if I re-index it and I give it a new value that doesn't exist, like E, re-index is going to induce a nan, whereas .loc using E is going to throw an error, right? So reindex, generally, you're going to kind of reserve that for, if you want to kind of take your data and kind of expand it a little bit, fill in some kind of missing locations or something, right? So for example, you have data from the past year or something, but you have some missing dates, right? So you got like January 1st, January 2nd, and then skips down to January 4th and January 5th and January 6th and things like that. And you go, you know what? I want to have all 365 days. So you can kind of create a date index going from January 1 to December 31. And then you can re-index your data according to that new index that goes from January 1st to December 31st. And it's going to kind of, it'll introduce nan values for every kind of place that's missing along the way. All right, I better speed up here. Okay. Let me give you your second view quiz answer. Second view quiz answer today is A as in apple, A as in apple. Okay, you can throw out columns or rows or whatever, okay, using df.drop, okay? So by default, when you say data frame drop, Okay, df being the name of your data frame, okay? You can do drop, and it's going to remove whatever rows correspond to the index here, okay? So here I've created the data frame, okay? And it's got index XYZ and columns A, B, C, D. And I can just say, you know, drop rows X and Z, and it gives me back, you know, what remains, which will just be row Y, okay? And if you want to drop the columns, you can say drop columns B and C, and you do have to specify axis equals 1. Okay, axis 0 is the rows, axis 1 will be the columns. Okay, otherwise you're going to get a key error. It's going to say, I can't find the index. I can't find a capital B, right? I only see XYZ as far as the rows go. I don't see a B or a C. So you have to specify axis equals 1 to drop your columns, but you can do that using you know, the name of your data frame. In our case, my data frame is called df, and you can do df.drop, right? Df drop returns a new object, and so even after calling drop here, drop, you know, these rows, drop these columns, the original df remains unaffected, and that's not changed. Okay. With pandas, all of your values and series and data frames and things, those are going to get aligned using the index, all right? And this is kind of a key departure from R, all right? So there's a lot of similarities between Python and R and how it handles kind of these vectorized operations. But a key difference is that everything with pandas is going to align the index first. Whereas if you're doing stuff with R, it's kind of up to you to make sure that your vector is in the order that you want. With pandas, it's your responsibility to make sure the index is accurate, and then pandas will always align the index, okay? So here I'm creating 2 series, okay? And so series 1 has the index A, C, D, and E, so it's missing value B, okay? Series 2 has A, C, E, F, G, okay? So it's missing a B, it's missing D, but it has F and G, okay? And so we've got, you know, kind of these values here, these values here, and as far as the index goes, this is what we go, right? And then so I think, you know, Akshat had a question earlier about, you know, what happens if you create a data frame using series that have different index values, all right? And so this is what happens, right? So I'm creating a data frame out of these series that have different index, and so where you have an index value that's missing, and that exists in one but not in the other, it's going to introduce a nan, okay? Now, pandas has no kind of contextual idea here, and so it doesn't see a B, and so it's not going to create a B for no reason, okay? Now, if we wanted to, we could create a new index, A, B, C, D, E, F, G, and then re-index accordingly, okay? But anyway, if I do S1 plus S2, if I say, you know, add up these series together, all right, and again, these are the series directly. It's not even, here I created this data frame just for your reference, but I'm not referencing the data frame directly here. Here I'm just saying take series 1 and add series 2, and it's going to line up these values. So A, you know, 7.3 minus 2.1 or plus a negative 2.1 gives me 5.2. C, negative 2.5 and 3.6 add up to 1.1. D, which is 3.4, and a missing value is going to return missing. Positive 1.5 and negative 1.5 add up to 0, and the missing values plus anything will return a missing value. So it lines up the values according to the index, and it returns this, okay? And notice that you know, we have different index values, right? Okay. You can also call, instead of doing plus, you can do S1 dot add. So you can take one series and you can do a dot add and give it the name of the second series, and you're going to get kind of the same values as well, right? So you can use the plus operator. You can also call the plus add or dot add method from a series, and you'll get similar values. Okay. And again, here's just the values just for your reference. You can also, there's similar ones like dot sub for subtraction. And there's a similar, and there's something called R sub, okay? R sub is subtraction, but it's right-hand side subtraction, right? So when you do subtraction, it's gonna take series 1 minus series 2 is basically what it's gonna do. When you do S1 dot subtractions S2, And here I'm using a fill value for all of the nans. So anything that's missing, we're going to get a nan. So 7.3 minus a negative 2.1 results in a 9.4. Okay. R sub does right-hand side subtraction. So it's going to do S2 minus S1, right? So as far as subtraction goes, it matters which one you put first and which one you put second. And so if you do right-hand side subtraction, you're going to basically get the negative of all of these answers. And that's what we get. Okay, so there's a sub and an R sub, and that's going to be right-hand side subtraction. Okay, there's you can do dot multiply or star for multiplication, element-wise multiplication. Element-wise multiplication will give you nans anytime you have a nan. If you want to have something where it's going to have a fill value, you can use the dot multiply, and you can have a fill value 1, and then it will be able to multiply things if you want to multiply series together. Okay, and if you have data frames, it's going to be similar. All right, and so here I have 2 data frames and that have similar columns and similar rows, but not exactly the same, right? So I've got Ohio, Texas, Colorado for the index rows. I have Utah, Ohio, Texas, Oregon. So Colorado exists over here, but not over here. And Utah and Oregon exist here, but not over here. Over here, I have B, C, and D. And over here, I have B, D, and E. Okay, and then I just have some values in here. And so if I do some kind of mathematical operation, it's going to align the index rows and the column indexes accordingly, right? So as far as the columns go, I've created a list out of, B, C, D, and as far as the rows go, I've created the index, this way. Okay, and so if I do df1 plus df2, all right, it's basically going to align the values that it can, right? So as far as here, we've got the only values that align are Ohio B, Ohio D, Texas B, and Texas D, okay? Because everything else, there's nothing to align for Utah, nothing to align for Oregon, nothing to align for column C, nothing to align for column E, okay? The resulting data frame ends up being the union of all index rows and all column indexes as well. So I got B, C, D, E for the columns. I've got Colorado, Ohio, Oregon, Texas, Utah, and notice, again, because we have 2 different indices, it's by default, it alphabetizes the row index, okay? And so with all of these things that are missing, we got a bunch of nan values, but it did add up the values for 3.0, Ohio B, Ohio D, Texas B, and Texas D, okay? So the result is a data frame with kind of the union of the index and things like that, right? Accordingly, you can also do df1.add and specify a fill value, and you'll get fewer nans here. And so so now we have things like this, and we have no value. Colorado E didn't exist in either of them. Neither we have Oregon C or Utah C, but now we have a bunch of values after we've added them. Assume using a fill value of 0 here. Okay, and so those are things that you can do. There's a whole bunch. I mean, just basic mathematical operations exist. So you have add and multiply, subtract, and divide. There's also right-hand side add and right-hand side multiply, which honestly, I don't really know, because addition is, the order doesn't matter. So I'm not sure if there's a difference between add and right-hand side add, but I don't know. I guess there might be. But you got right-hand side subtract, right-hand side divide, floor division, and exponentiation with the power. Okay. You can create summary stats for a data frame based on either series or indexes. And so here is a data frame I've created, index A, B, C, D, E, F, G, columns 1 and 2, and I've just got some numbers in here, okay? 1.5, 6.0, nan, 1.5, et cetera, et cetera, et cetera, okay? And so you can do something like dataframe.sum, and the default behavior is going to go over the columns and give you the return. It's going to give you the sum of whatever it gets, okay? And by default, it's going to sum across axis 0, meaning it's going to basically collapse axis 0 down to 1 row. And so, we get a value for value for column 1, value for column 2, and it replaces all nans with zeros, at least for the sum. Okay, for product, it's going to replace more nans with ones. Okay, for DF, you can specify axis equals 1, and that's going to collapse axis 1. So it's going to collapse the columns down into 1. And so, the sum of 1.5 and nan is 1.5. The sum of 6.0 and negative 4.5 gives me 1.5. And these add up to 0 and 4.0 and 0 and et cetera, et cetera. We get these. Okay. You can also specify, you can say, don't skip the missing values. Don't skip them. And then you'll get missing values, right? Because anytime you add a missing value to something, the result is going to be missing, right? So we have nans here. Okay, you can also ask for the mean. And again, by default, it's going to collapse axis 0, collapse the rows into one value, giving you a column mean. Okay. And again, skipping the missing values. You can also specify axis equals 1. All right. There's a few other things that are useful. You can ask for the minimum value in the column, right? And so the minimum value here is 1.5. The minimum value in this column is negative 4.5. Okay. You can also ask for IDX min, and that's going to ask you for what's the identity of the minimum value, right? So you have min and max, and you have IDX min and max. And so it's going to say, over here, the minimum value is 1.5. What is the name of the index of that value, 1.5? And here it's going to say 1.5 corresponds to index A, right? Index of minimum value is A. And it's going to give you the first, right? So if there's multiple, here we have a tie for the minimum at row A and row D. Okay, it's just going to give you the first one here. Okay, so even though D qualifies, it counts, right? And as far as the minimum for over here, the minimum was negative 4.5, and the row that corresponds to negative 4.5 is row B, and that's what we get here. All right, and then there's a bunch of these things that you can also do. So you can kind of ask for other summary values. So you can ask for the count and the quantile, the sum. We already seen sum and mean, and you can also get median and the MAD and the product and the variance and the standard deviation. And then there's more as far as, what kind of computations you can do for descriptive statistics go. Okay, let me go ahead and give you your last view quiz answer for today. Last view quiz answer today is B as in bear. B as in bear for your last view quiz answer. We got a few more slides to cover here. You can take a series, right? So we can say go to column 1. So in data frame column 1.1, you can ask for the unique values, right? And it just kind of gives you the unique values in the order that they're encountered. So it says, okay, 1.5, that's unique. 6.0 is unique. Missing value nan is unique. It counters 1.5, so it kind of skips over. We get 4.0, and it puts that in. 6.0 it's seen before, nan it's seen before. So this gives you kind of the unique values in the order that they've been encountered. Okay, same thing for, you can do it for the other column, df.to.unique, and you'll get the values there. Okay, if you call df.unique without specifying one of the columns, the .unique only exists for a series. So it's going to complain. It's going to say, I can't do this, right? It can only apply to a series. So just basically a column in the data frame. It's going to be able to identify unique values. Okay. Again, here's just the data frame. You can also ask for how many unique values, and it's going to say, you know what, there are three unique non-missing values. So nan is not counted as a unique value. So it says, okay, we got 1.5, 6.0, and 4.0 as far as the number of unique values that aren't missing. Okay. You can also do something called value underscore counts. And this is going to kind of tally up how many times it's seen each of these values. So it says 6.0 we've encountered twice, 1.5 we've encountered twice, and 4.0 we've encountered once. Okay. So dot value counts is useful for kind of creating a tally, almost like a histogram, but it's, again, they kind of just go and they appear in descending order of frequency here. You can also, there's a method called isIn, and you can just kind of take one of the series and you can say, is that value one of these values? Is the value in this this list that I'm giving it, 1.5 and 4.0, and it says, as far as A, that counts. 1.5 is in 1.5 or 4.0. So basically it's going to get true for A, D, and E, and false for everything else. And that's what we see. A, D, and E is true. Those values for column 1 is in 1.5. You can also do bitwise arithmetic or bitwise Boolean logic here. And you can say, is df1 equal to true 1.5, or is df.1 equal to 4.0, and you'll get the same results. But this is not preferred. Okay, the dot is in the preferred method there if you're trying to kind of filter and identify certain rows, right? So if you got some kind of thing and you want to say, I want to just narrow it down to people in California or Texas or something like that, you can say is in California, comma, Texas or something. Okay, and then once you have that kind of logical vector or logical array of whatever it is, you can then subset the data frame using the dot location, right? So you can do df.location, and you can give it pass it that argument, and then it will just give you a subset of the data frame where column 1, the value in column 1 is either 1.5 or 4.0. Right? So you can, a lot of these things you kind of start off and then you expand and you build up. Okay. As far as missing values go, you can also just filter them out. Okay. And so here's some things. So one is you can do drop NA. Drop NA is going to drop any row that's not complete. So if there's a missing value, it's going to get dropped. So this gets dropped, row C gets dropped, row G gets dropped. Okay. So anything that has a missing value gets dropped. So we just do drop NAs. Okay. You can also specify something like how equals all inside drop NA. And this is only going to drop rows that are entirely NaN. Okay. So as far as our data frame goes, row C has only NaN values. Okay. So that's the only row that's going to get dropped. Okay. If you say all the values have to be missing for it to be dropped, then it will do that. Okay. And so A is preserved and G is preserved, even though they have missing values. It's just because not all of them are missing. Okay. And then, you can also specify the dot not null in, and, as far as one of the series goes. Okay. And so this will drop any, so here we're subsetting the data frame, pulling back all rows where column 2 is not missing. So I've got df.2.not null, and we're using this in conjunction. And so df2.not null would return kind of this Boolean array of, whether 2 is a missing value or not, and we'll get the values there. Okay. You can fill in missing values. This is often a handy function. So you can fill in with things like some constant. You can fill in the missing values with a 0. You can fill in with a dictionary, and you can say, what, if it's in column 1 and it's missing, fill it in, replace it with the value 1000. And if it's in column 2, replace column 2 with the value 0 or something like that. Okay, so that can be handy. Another thing is you can use backfill. All right, so this could be useful. So if it's missing, it's going to backfill the values, right? So this gets backfilled. Okay, and of course, if you can use backfill, you can also use forward fill. You can also fill in with the mean of the column, right? So here I can say, what's the mean of the data frame? df.mean is going to say, okay, well, 1 gives me 3.8 and 2 gives me a mean of negative 1.3. And you can say, fill in the missing values with the mean of the column, right? And so the missing values here at row C and row G get filled in with 3.8. And at column row A and row and C get filled in with negative 1.3. Okay, that can be handy. Also potentially dangerous with if you just do it blindly, okay? But it's a common thing if it makes sense to do, may or may not, okay? All of these kind of fill NA methods have created new data frame objects. And there is an argument that you can specify in place equals true is going to modify the data frame directly in place, okay? Rather than giving you back a copy. All right, and I know I'm a minute over, but I'm just going to show you this. Sometimes you want to fill in missing values across. So where do my missing values go? Okay, so maybe you want to fill in column 2 with the missing value of 1.5 and column, the value over here in row G with the value 4.0, okay? When you do fill NAs, it defaults to working in columns. So what you can do is you can transpose it, fill in the values using the columns, and then transpose it back. Okay, so this is a little bit of transpose magic, I guess. And so I'm transposing it to do this, and I'm going to say fill it in using the columns here, and then transpose it back, and then we get what we want. 4.0 fill in. This NAND gets filled in with 4.0. And this NAND gets filled in with 1.5. Okay, all right, I got a couple slides on duplicates. This is basically, it's kind of like unique, except it applies to a data frame. So if there is an entire row that's duplicated, which F is a duplicate of row B, then you'll get that. Okay, so this will kind of say row F is a duplicate of something else. So that's going to give you true. And you can say, you know what, give me everything that's not a duplicate. You can also specify for one column, and you can say, are any of these things duplicated and things like that. Okay, that's a bunch of stuff as far as Pandas goes. There's still a lot more that we can do, and so we will cover, spend even more time on Pandas, just because this is really going to be kind of important as far as summarizing and working with data here. So we'll end here for today, and we will see you guys on Friday. So have a good night. We'll see you then.